Page 25. We can solve two simultaneous equations by substitution and not graphing. We do this with basic algebra. So when we look at these two, this is a system of equations, we can just simply replace this y for this y. They're both the same. This y, by denoted here with this equation sign, is equal to x plus 1. So if we can replace these and interchange these, and this is also this, we can simply plug this in for this y right here. So let's go ahead and do that. That's replacing. We're going to replace it, and then we'll only have x variables, and we can solve for x. Let's do that and you'll see what I mean. So let's rewrite this out, but instead of the y here, we're going to use this instead of y. So 2x minus 3, but not y. Let's put a parentheses so we can put this in there, this whole term, both these terms. X plus 1 instead of y. Close parentheses there, because you're timesing it to this, equals 2. Okay, so all we have to do is distribute this 3 out to both of these, and then we'll have something that looks a little bit more recognizable. So rewrite it. 2x minus 3 times x is 3x, or I should say negative 3 times positive x is negative 3x. Negative 3 times positive 1 is negative 3. So we distributed it out, and then finish the equation. That equals 2. Now we have something that's a little bit easier. We can, as you see, these are like terms. We can add those together. So a negative 3 plus positive 2x, or negative 3x I should say, plus 2x, positive 2x, becomes just negative x. And then minus 3, because that's this remnants over here, this one, we haven't resolved that one. It's not a like term. And then equals 2, just finish it out. So now let's go ahead. We want this to be a positive sign because it's easier to work with. So let's just get it to this sign, change the sign by plussing it to both sides. And this is fine because it's not changing anything about the equation, we're just rearranging it. So plus x to both sides, these two will cancel out, and you'll have negative 3 equals 2 plus x. Go ahead and subtract now 2 from each side to isolate them. I don't need that sign. Okay, these two right here, and this is nothing, I messed up here. So these cancel out right here, and then negative 3 minus negative 2 is just negative 5. And that's all equal to x. Okay, so we figured out what x is. How do we figure out y? Because when we're looking at an ordered pair, which is the solution to both the x and y variable for each of these equations, and let's go ahead and put a left bracket to show it's a system of equations. So we need to find both of these variables. We figured out x. X is going to be negative 5. To figure out y, we can simply plug in, just substitute this x into one of these. So the easiest one to work with is probably the simplest, just the top one. So let's just plug in a negative 5 for the x up here, and then we'll figure out what y is. So rewrite it. Y equals, not x, we're going to replace it with negative 5. Negative 5. So plus 1. That becomes y equals negative 4, because negative 5 plus 1 is just negative 4. So we figured out both of them. Let's go ahead and write it out in ordered pair form. So the first one was -5, if you remember what x was. Separate that with a comma, and the next one will be -4. Figure that out. Now the last step is to check. Let's check our work. Let's go ahead and plug it into, this top one here is pretty easy to see. We can just plug it in here. We know that we've already plugged in the -5 here. If we plugged in the -4 here, that would equate. So now let's try the bigger one. So we know it works for both. So 2x, so that will become 2 times -5, because that's what x is. 2 times -5 minus 3 times -4. And that should equal 2. Let's see if that's actually true. So this becomes -10. -10. This is minus. Actually, it's not minus. It will be plus, because a negative times a negative becomes a plus. That's the rule. So this is actually going to be a plus 12. Right there. 3 times 4. That should all equal 2. Well, we know that if we subtract this 10 from the 12, we will get 2. So this comes out to 2 equals 2. So we've checked it. There you have it. We know that, in fact, this is the correct ordered pair. Let's just go through the steps right now. Just to recap what you've done, what you've learned here. The first thing you're going to do when you solve these things, you're going to look at this and you're going to replace one of the variables. In this case it was the y here. You're going to replace it with what the other equation says y is. So it was right here. So this step is replaced. Once you do that and you come up with a solution right here, go ahead, substitute it back into one of the equations. When you substitute it back in, you get both of them, you have an ordered pair, and then you'll just check it. And in your pace, it might show one more step, which was to solve, and this was just this. I just assumed that when you were replacing, you'd both solve for this. So this is both solve, replace and solve. So if you're looking at your pace, there's no inconsistencies. There is replace, you solve it for that variable, then you substitute it, and then you'll check it. And that's how you do it.